my name is Alex, and now we're going over challenge exercise 1. Assume vector a to b is equivalent to vector a prime to b prime. Vector bc is equivalent to vector b prime to c prime. Proves that vector ac is equivalent to vector a prime to c prime. So in the book, it talks about definition 2.3, wherein two like segments are equivalent. They have the same length, they're parallel, and they point in the same direction. And this is illustrated in this graph right here. So vector a to b is going to be the same length as vector a prime to b prime, and it's going to be the same thing with vector b to c and vector b prime to c prime. And so in definition 2.8 in the book, it talks about vector addition. And if you have vector ab plus vector bc, then the sum is going to be vector a to c. And the same thing is going to be for vector a prime to b prime plus vector b prime to c prime is going to equal to vector a prime to c prime. And since vectors ab and vector a prime to b prime are equal, same length, and vector bc is equals vector b prime to b prime, then the sums, which are vector ab plus bc and vector a prime to b prime plus vector b prime to c prime, they're going to be the same. And so therefore vector a to c is going to be equal to or equivalent to vector a prime to c prime.